In this video, we're going to work Algebra 2 Homework 11.2. So let's get to it. So first, when we're finding the value of an inverse function, all we're going to do is just like set f of x equal to, in this case, 1. So I'm going to say f inverse of 1, we're going to set f of x equals 1. And we've got a formula for f of x, that's 4x plus 5. And I'm going to solve for x by subtracting 5 from both sides. And then, I'm dividing both sides by 4 and getting x equals negative 1. So I'd say f inverse of 1 equals negative 1. For b, g is going to be absolute value of x minus 2, and we're going to find g inverse of 3. So that's like solving the equation g of x equals 3, which is going to look like absolute value of x minus 2 equals 3. And then, if we're going to drop the absolute value, we're going to have a plus minus. Or you can say if the absolute value of a number is 3, then that number is either 3 or negative 3. Either way, we'll have x minus 2 equals plus or minus 3. I'm going to add 2 to both sides of this equation, and I'm going to say x equals 2 plus or minus 3. Right? In the event it's plus, it's going to be 5. In the event it's minus, I'll have negative 1. And so I'll say g inverse of 3 is equal to the set that has negative 1, 2 minus 3, and also 5, 2 plus 3. Next one is x squared plus 6x, and we want to find h inverse of negative 9. So that's like solving the equation h of x equals 9. And that would be like x squared plus 6x equaling negative 9. Okay, and if we've got a quadratic and it's got more than one different power of x in it, I need to set the thing equal to 0 so that I can solve it. Okay, and I'm looking at this, and I'm hopeful that we'll be able to factor. Okay, so I've got x squared plus 6x, add 9 to both sides. That's equal to 0. And so now I'm kind of left with looking for two numbers that multiply to 9 and add to 6. Oh, 3 and 3. So I'll have x plus 3 times x plus 3. That's x plus 3 squared equals 0. I'm looking at this equation. I can see that this equation is only going to be true when x is negative 3. And so I'm going to say h inverse of 9 is just equal to negative 3. So there's only one value that I got back. So let's see. Next we have d is f of x is x to the 3 minus x. We're interested in finding f inverse of 0. Right, so we're going to set f of x equals 0. So f of x equals 0, which is telling me x to the 3 minus x needs to equal 0. And this is the type of thing that we could factor on, right? It's got a greatest common factor. It's got x on both of them. So I'm going to start there. I'd say x times x squared minus 1 equals 0. And x squared minus 1, that can be factored too. That's a difference of 2 squares. So I'm going to have x times x plus 1 times x minus 1 equaling 0. So this would be true when x was 0 or negative 1 or positive 1. So we would conclude that f inverse of 0 was the set that had all three of these values in it. Whoops, for the brace. That's all right. All right, E is going to be, I might need to copy that one. I'm looking at it. All right, so we're solving g inverse of 5, so that's like solving the equation g of x equals 5. And with 2 plus the square root of x plus 1 equals 5. All right, and so what I'm going to do is subtract 2 from both sides. Okay. Then I'm going to square both sides, and I might remind you that when we squared both sides of an equation, we were solving a rational equation, or a radical equation. We did need to check for extraneous solutions. I don't think that's going to happen here, though. So I'm going to square both sides, and I'll have x plus 1 equals 3 squared, which is 9. And then you subtract 1 from both sides, and you've got x equal to 8. So I'm going to say g inverse of 5 equals 8. For f, h of x is 2 to the x minus 5. No, but I forgot what I was supposed to be looking at. Okay, h of x is 2 to the x minus 5. Find h inverse of 9. Okay. So I'm solving h of x equals 9, and h of x is 2 to the x minus 5. Okay. Now, had this been 2 to the x minus 5 equals 8, I would know that x minus 5 would need to equal 3 because I know that 8 is 2 to the third. But I don't know what power of x I put on 2 to get 9, so I need to take a log of both sides. Okay, so to get this x minus 5 down out of the exponent, I need to take, a log and probably a log base 2 because we want a log with the same base as the base of the exponential. So log base 2 of 2 to the x minus 5, that's going to equal log base 2 of 9. These things, they kind of undo each other. And so I'm just going to have x minus 5. Or I could think about, this log as the exponent I put on 2 to get 2 to the x minus 5, which would be that x minus 5 exponent, however you want it. And then I'll solve for x by adding 5 to both sides. And I'll see, all right, x equals 5 plus log base 2 of 9. And so I'll report that h inverse of 9 is equal to 5 plus log base 2 of 9. G is going to be 1 plus 2 natural log of x. F inverse of 0. All right. So f inverse of 0, that's where f of x equals 0. And f of x is 1 plus 2 natural log x. We're going to subtract 1, divide by 2. And if I want to get rid of this natural log, I need to take e to both sides power. So I'm going to say e to the natural log of x, that's just x, equals e to the negative 1/2. Now, if you want to call this 1 over the square root of e, you can. You know that. We've learned that in this class. But you don't have to. We could just say that f inverse of 0 equals e to the negative 1/2. And that would be enough. Okay. Then for 1h, I've got g of x. Okay, if I want g inverse of 2, I want g of x equals 2. So that's 2x plus 5 over x minus 3 equals 2. Oh, whoops, didn't realize it wasn't on the screen anymore. And then I'm going to multiply both sides by this x minus 3. So I'd have 2x plus 5 equals 2 times x minus 3. I could distribute the 2. And then maybe subtract 2x from both sides. Yeah. And then I get 5 equals negative 6. That's not true. No solution. G inverse of 2 doesn't exist. Oh, wait. No. Yeah, I might say D and E. You can say it equals the null set if you like, but I think I'll probably just stop there and say it doesn't exist. All right, now we're going to move on to number 2, and we're going to determine if these pairs of functions are inverses or if they're not. And we're going to justify our answers. And how we're going to check that, and how we're also justifying our answer, is by doing composition functions. F of g of x needs to equal x, and g of f of x needs to equal x in order for these two things to be inverses. So for this first one, I'm going to say f of g of x is, okay, anywhere I see x in the formula for f, I'm replacing with g of x. So g of x squared plus 1, which is going to be this square root of x minus 1 squared plus 1. Okay, now, in the lesson, I showed you one where this worked out. This one's not going to work out. You can't just square the square root and square the 1, unfortunately. Okay, that would be too good to be true. What I'd have to do is, do FOIL. So, I think for the sake of the example, I'm going to do it. Okay, so I would have this x, and I would have the plus 1 at the end, but I'm also going to have 2 of these negative 1 square root x's. So that's x minus 2 square root of x plus 1 plus 1. That's not equal to x. Therefore, f and g are not inverses. You could have done the same thing with g of f of x, because when you plug in x squared plus 1 into the square root, you cannot just take the square root of x squared and the square root of 1. Okay, that's something that we tried to do quite a bit in my class when we were studying radicals, and you can't do that. That's illegal algebra. So 2a, these are not inverses. No, we justified our answer. All right, for 2b, we've got x squared minus 3 and the square root of x plus 3 with the plus 3 on the inside. And I do think these are going to be inverses of each other. So let me fold my paper. And f of g of x is going to equal, okay, g of x squared minus 3, which is going to be, I square that square root, I get an x plus 3, and then subtract 3. Hey, that's just x. That's a good sign. Okay, now we'll try g of f of x. And that's going to be, all right, well, g of x is the square root of x plus 3, so g of f of x will be the square root of f of x plus 3. But if I take f of x and I add 3 to it, I'll just have x squared minus 3 plus 3. It's just x squared. So I'm taking the square root of x squared, and that's just going to be x. Okay, happy. Yes, they are inverses. Okay. For 2c, oh yeah, I got a little, these are a little tricky, so that's why I put 4 of them. 2 of them are going to be yes, 2 of them are going to be no. That's what I would expect. I've been doing these homeworks I've written for a while now. I usually expect if it's yes and no, and there's 4, you should have 2 of each. All right, so I'm going to try f of g of x. All right, so that will be equal to e to the 2 times not just x, but g of x. Okay, so that's going to be e to the 2 times the natural log of 1/2 x. Oh, okay, we could do this. Okay, this is like power of a power. So this is equal to, I'm not sure how else you would know, but there's not really, like, or you could try to do the power, and this is just not going to come back x. But I'm going to say that this is e to the natural log of 1/2 x. That's what we know how to do, is take e to a natural log power. But then taking it to the squared, or taking it to the second power, where we would multiply these exponents. That's what I'm going to do. So this is 1/2 x squared, and that's not equal to x. So I'm going to say they're not inverses. Had I done g of f of x, I think I'd have, yeah, 1/2 e to the 2x is not just the same as e to the 1x. Okay, so it wouldn't have worked the other way either. And so for D, I'm hoping that, provided I've thought about it correctly, we'll have ourselves a pair of inverse functions. So for this one, f of g of x is going to be 2 to the g of x divided by 3. Okay, well, g of x divided by 3, okay, I'd have 3 times the log base 2 of x divided by 3. Well, 3 over 3 is 1, so that's just 2 to the log base 2 of x, and that's x because these things undo each other. G of f of x is equal to, okay, g of a thing is 3 times the log base 2 of that thing, so it would be log base 2 of f of x. So this will be 3 times the log 2 of 2 to the x over 3. Again, okay, these things are, oh, whoops, didn't realize you couldn't see that. Probably should zoom out a little bit. They're inverses of each other. They undo each other. It's a fundamental identity that the log base 2 of 2 to a thing is just that thing. So I've got 3 times x over 3, and that's equal to x. So yes, they are inverses. And that's all for number 2. Number 3 is asking for us to give a formula that gives x in terms of y. So basically just solve for x. So we're getting to the skills y'all already have built throughout the year in this class. So 3a, I'm going to start by, I'm trying to isolate x, so I'm going to subtract the 8. And you definitely, you could have distributed and simplified and solved for it the old way, but I figured I'd just do it in kind of what's most obvious to me. I might divide both sides by 2. And then add 3 to both sides. And like, yes, this is not the nicest formula for x ever, but it is a formula that gives x in terms of y. Okay, that's what we mean. That gives x in terms of y. X equals, and then everything on the other side that has y's in it. All right, the next one's going to ask us to solve an absolute value equation. So we always have to isolate the absolute value first, so I'll subtract 5. That'll be equal to the absolute value of x plus 4. Oh, whoops, absolute value. And then to drop the absolute value, we need a plus minus on the other side. But we want plus minus the whole thing, because if the absolute value of this number equals y minus 5, then the number either equals y minus 5 or it equals the negative of it. But if I'm solving for x, I just need to subtract 4 from both sides, and I'll have x is negative 4 plus or minus y minus 5. And I mean, like, you could simplify this if you wanted, but this is a formula that gives x in terms of y. 3c is a quadratic that's in vertex form, which is helpful for us, because if it's not, then we have to complete the square to write it in vertex form. And I'll probably have you do it once or twice, but that's not something I would expect to see on a quiz or a test. Maybe, are we going to ask you to do it here? No. Okay, I'll do a practice problem like that at the beginning of class next time, maybe. So 3c, y equals x minus 1 squared plus 2. I'm going to kind of try to get at this on its own so I can take the square root of both sides. So I'm going to subtract 2. Now I can take the square root of both sides, but square root of x minus 1 squared, okay, that's going to be plus minus over here. Okay, and the square root of x minus 1 squared, that would just be x minus 1, because we've got the plus minus there, and I'm going to add 1 to both sides, and I'll say x is equal to 1 plus or minus the square root of y minus 2. A few more of these. That's good. That's what we need to work on, is solving for x. That's what we're doing here. So C and D. Yes, and these are very similar. Or, no, D and E. So 3 and D is y equals x to the 3 plus 6. I think I meant to make that a cube root, but it's okay. We'll work it as it is. Okay, so we're going to start by isolating the x cubed. We're going to subtract 6 from both sides. Then I'm going to take the cube root of both sides of the equation. And I don't need a plus minus because the cube root of a number is unique. Like, we can take the cube root of a negative number and it comes back negative. There's only ever one cube root of a number. Which is really not to say that there's 2 square roots of a number, but we've talked about that enough in this class, why you have a plus minus when you take square root of both sides. Just reminding you don't need the plus minus when you take the cube root, or say like the 5th root or something like that. So 3e y equals the square root of x plus 6. Okay, there's not anything I can do to simplify this right now besides square both sides. And x by subtracting 6, so x equals y squared minus 6. Yes, and so, yeah, the difference here was that, because the plus 6 here was on the inside of the square root, it ended up being on the outside of the square when I solved for the inverse. And this was the opposite. The plus 6 was on the outside of the cubing. This wasn't like x plus 6 cubed. As a result, the 6 went on the inside of the cube root. That's what I was trying to point out there. Okay, F and G, these are kind of also somewhat related. Exponential and log. Okay, so 3f. Y equals 3 to the 2x plus 4. When we were solving these exponential equations, we had to isolate the exponential. It's like we had to isolate the log, or isolate the absolute value, whatever. Isolate the radical. It's always been a theme. We start with isolating. So I'm going to subtract 4 from both sides. And then I'm going to take the log with base 3 of both sides. Now, if you wanted to call this 9 to the x, you could. Your answer would look different, but it would be equivalent. So I'm going to take the log base 3 of y minus 4, and that will be equal to the log base 3 of 3 to the 2x, which means that this log is equal to just the 2x. Let's scoot this up a little bit. And I could solve for x by dividing by 2. Okay, and that's a formula that gives x in terms of y. All right. I'll be able to fit all 3 of these on this scrap of paper. So 3g is going to be y is equal to the common log, which is log base 10, I always like to just write that in, of 2x minus 5. Okay, so to get rid of that log's already isolated. So I don't need to do any work to get it on its own. Got it's on its own, I'm going to take 10 to both sides power. 10 to the y is equal to 10 to the log base 10 of 2x minus 5. So 10 to the y equals that 2x minus 5. Access that x by adding 5 and then dividing by 2. So 5 plus 10 to the y equals 2x. Divide both sides by 2. X is going to be half of 5 plus 10 to the y. And then 3h. Y equals 1 over x plus 1. Now this, hold on, let me think about this. All right, I see two different ways to approach this, and I think I'm just going to show you both of them. I'm not going to, this is another one that's like maybe a little beyond what I would expect for you to be able to do, but this is homework, so I figure I might extend it a little bit. I'm going to multiply both sides by the denominator to get rid of it. So I'll have y times x plus 1 equals 1. And then, okay, it looks like I need to distribute, so I can do that. Yx plus 1y equals 1. And then what we need to do is solve for x. So let's just try to get the yx on its own. I'm going to subtract a y. So that's 1 minus y. And then to solve for x, I could divide both sides by y, because I'm multiplying by y, so to get rid of it, I need to divide. So x is 1 minus y, all divided by y. And that would be a formula. Now, another thing I saw is that you could have written y equals, I'm really running out of room here, x plus 1 to the negative first power. And then I could have taken both sides to the negative first power, like the reciprocal power. So y to the negative 1 equals x plus 1 to the negative 1 to the negative 1. And negative 1 times 1, negative 1 is positive 1. So I've got y to the negative 1 equals x plus 1. I could say x equals negative 1 plus y to the negative 1, which it doesn't look like it, but this is equivalent. Okay, the negative 1 is from these two, and the 1 over y is right here. That's enough of that. Now we're going to use the table to find the values. And I know that this is one where we could probably fit our answer in with the questions, but we're disciplined. We're using a separate sheet of paper, okay, because we know I'm not going to give you credit if you work your problems on the sheet. We're just a little bit beyond that now. But honestly, if I was teaching Algebra 1, I'd be saying the same thing. We need to show our work on a different sheet of paper so we can space it out, and we can actually, you know, if we're making an error, we can analyze it. But because if we're trying to cram all of our work in, it's very little chance of us being able to analyze errors if we make them. So f inverse of 5, that's where f of x equals 5. Okay, look on the column for f of x, that equals 5 when x equals 1. Okay, so I'm going to say f inverse of 5 equals 1. G inverse of 5, same thing. G of x equals 5. I found it here, backtracks to x equals 3. So I'm going to say G inverse of 5 equals 3. Okay. F of G inverse of 1. Okay, I'm going to go a little bit faster on this one, third one. So that's going to be, what is G inverse of 1? Okay, G of x equals 1 at x equals 4. So this is going to be f of 4. F of 4 is 3. Okay. Then, okay, I've got the opposite. I've got f inverse on the outside. So I'll just evaluate g of 2. G of 2 is equal to 3. And now we're taking f inverse of 3, which is going to be 4. F of f inverse of 3, this is something I didn't talk about a whole lot in the lesson, but because inverse functions, they undo each other, I already know that's going to equal 3. Okay? Because f of f inverse of x needs to equal x. That's that thing where we're checking to see if two things are inverses and it has to return x. So I'm just going to say that equals 3. But the reason why, f inverse of 3, I go and I find 3 in f, I backtrack to x, okay, so f inverse of 3 is equal to 4. So I'm taking f of 4, and that's 3, which is exactly what I would expect. Okay, so the same thing here, g inverse of g of 1, I'm going to say that's equal to 1. But I can say that because g of 1 is equal to 2, and g inverse of 2 goes back to 1. Okay, so that's, we're doing that with the table. And nice little interlude to break up the solving, because now we're about to find f inverse of x, 12, 13 times, and that will, it'll take a while, and so I thought I'd just break it up with the table one, and then we'll end with a graph example that should go pretty fast. So, get out my separate sheet of paper and get to work in here. All right, so finding f inverse of x. What I'm going to do is I'm going to solve for x, and then I'm going to switch x and y, basically. So y equals x squared plus 7, meaning y minus 7 equals x squared. And x is going to be plus or minus the square root of y minus 7. So that means that f inverse of y, that's what I found when I solved for x, f inverse of y is plus or minus the square root of y minus 7. So f inverse of x is going to be plus or minus the square root of x minus 7. B, I've got y equals x plus 8 squared. So this is kind of to contrast against, where was it? It was back here, x to the third plus 6, where we're adding 6 on the outside of the cubing. This is kind of the opposite. So I'm going to take the square root of both sides right now to get rid of the thing on the outside. And then I'll solve for x by subtracting an 8 from both sides. So I'll say, well, f inverse of x is going to be negative 8 plus or minus the square root of x. So that was b. C is x to the 3 divided by 2. Hey, also you can kind of think about this as like reverse order of operations, PEMDAS. I need to deal with addition and subtraction first. I don't see any of that. Then I would go backwards to multiplication and division. Okay, well I need to get rid of that too, so that'll be 2y equals x cubed. And then last of all, we'll deal with exponents. So to solve for x, I'm going to take the cube root of both sides and get x equals the cube root of 2y. Meaning that f inverse of x, okay, this is f inverse of y, f inverse of x will just be replace y with x, and there we go. D, f of x, wait, no, y equals x over 4 cubed. And then I might take the cube root of both sides. And then to access x, I would need to get rid of that 4, which is divided, so I'll do the opposite. I'm going to multiply both sides by 4. X is going to be 4 times the third root of y. And then okay, that's f inverse of y. I'm looking for f inverse of x. I'll say f inverse of x equals 4 times the cube root of x. Right, so e is the square root of 5x. So okay, I've got the radical isolated, so now I'm going to get rid of that radical. I'm going to square both sides. So y squared equals 5x. And if I'm trying to get x, I'm going to divide both sides by 5. And I'll say x equals 1/5 of y squared. So to get f inverse of x, I'm going to switch x and y, and I'm going to say, all right, that's 1/5 of x squared. F is y equals 6 square root of x, like the exact opposite. So I don't have the radical isolated. I need to get rid of the 6 that's multiplied, so I need to divide. So I'll say y divided by 6 equals the square root of x. And I'll square both sides. I'm just going to call that y over 6 squared. But you could call that y squared over 36 if you wanted, because we're going to square the y and square the 6. So I multiply y over 6 times y over 6. And I'd say, all right, f inverse of x is going to be y squared over 36, I guess, or y over 6 squared. Doesn't matter, same thing. Right, f. G is cube root of x minus 1. Y equals, yep, you can see that, cube root of x minus 1 on the outside. So I got to isolate the radical. I'm going to add the 1 over here. And then I'm going to cube both sides. And although we could go and multiply y plus 1 by itself 3 times, I'm not going to recommend you do that. Okay, because you're not going to be any more right than you would be to just say f inverse of x equals, instead of y plus 1 cubed, x plus 1 cubed. And h is similar, but somehow a little different. Okay, y equals 1 minus x in cube root, so y equals cube root of 1 minus x. Okay, radical's isolated, so I'm going to get rid of it, take both sides to the third power. So I don't know, I'll do it differently. I'll add an x to both sides, then try by subtracting y cubed, 1 minus y to the 3. And so that means that f inverse of x equals 1 minus x cubed. Okay, let's see. I, J, K, L, and M. Let's see, just slide this sheet up and see some of my old work, but that's all right. For I, got y equals e to the 2x plus 10. So I'm going to start by subtracting both sides, subtracting 10 from both sides to isolate the exponential. I'm trying to get rid of e to the 2x. I need to take a natural log of both sides. So that will leave me with just 2x over here. And then to solve for x, I will divide both sides by 2. And like, yes, you could say that this is the natural log of the square root of y minus 10, but you wouldn't be any more right. Okay, so I'm going to recommend you not do a whole bunch of simplifying on this when we're just trying to write an equation for f inverse of x that would work. That's just going to be 1/2 of the natural log, instead of y minus 10, x minus 10. And j is also an e to the x situation, but, oh, okay, I switched around the 2. So y equals 2 e to the x plus 10. So we need to isolate the exponential. Okay, last time we subtracted 10, because that was the opposite of adding 10. This time we're multiplying by 2, so we need to divide by 2. So 1/2 of y equals e to the x plus 10. Then I'll take natural log of both sides. Log of 1/2 y is going to equal the natural log of e to the x plus 10. Well, that's just x plus 10. Then I'll solve for x, running out of room here. Negative 10, I'm subtracting 10 from both sides, so negative 10 plus the natural log of 1/2 y. Then if I needed to write f inverse of x, which I do, and say f inverse of x is negative 10 plus the natural log of 1/2 of x. All right. Rotate the paper now. Okay, f of x is log base 4 of 2x. So to get rid of this log, I need to take 4 to both sides' power, because the base of the exponential needs to be the same as the base of the log in order to just cancel them off nicely. So that's going to be 4 to the log base 4 of 2x. That's just 2x. Solve for x. I get x equals 4 to the y divided by 2. Now, unfortunately, we cannot say that this is 2 to the y. That's going to be something different. Okay? You could simplify this, but I'm going to suggest that you not, like I have been this whole time. F inverse of x is going to equal 4 to the x divided by 2. Resist the temptation to try to cancel that because we can't. Okay. Then L is going to be, it's kind of directly for comparison, so I'll put that one right underneath. L is y equals 2 times the log base 4 of x. Okay, so I need to isolate the log. Then take 4 to both sides' power. 4 to the 1/2 of y equals x. And like, yes, you could say that's 4 to the 1/2, which is 2 to the y. But I'm just not going to. Because, right, if you're unsure about it, you should just stick to what you're sure about. And that would be just switch x and y. So f inverse of x is 4 to the 1/2 of x. Maybe I'll put that in parentheses so you can see that's like the whole exponent. Okay, so that was L. One more for M. Y equals 1 over x minus 3. I'm going to multiply both sides by x minus 3. So yx minus 3y equals 1. Right, because I need to distribute the y over the x and the minus 3. You can look at this as cross multiplication also. Then I'm going to try to get x on its own. So I'm going to add 3y to both sides. So y times x equals 3y plus 1. And then I'll divide both sides by y. So x equals 3y plus 1 all divided by y, and that's I need f inverse of x. So I'm going to switch x and y, and that'd be 3x all divided by x. And yes, this thing could be simplified more by looking at this as 1 over x times that, but this is a perfectly good formula. I think I'm going to stop there. All right. Now, the last couple of problems we've got, look at the graph, find the values. Finish up on something a little smoother, less computation. So g inverse of 0. Okay. We're going to go over here. Stick a note. So g inverse of 0 is solving the equation g of x equals 0. I think we know that's the graph of g. Same graph from last homework. So g of x equals 0 right here at x equals -2. So I'm going to say g inverse of 0 equals -2. It's the x coordinate that gives me y equals 0. For b, g of x equals 1 is what I'm trying to find. Okay, that's it here where y is equal to 1. That traces back to x equals 0. So I'm going to say g inverse of 1 equals 0. And for c, g inverse of 4. So I'm solving where is y equal to 4. It would be up here, it looks like. That's x equals 3. G of x is equal to 5. Okay, go up to 5, and it's like, oh, no. Okay, but I can see that this is a slope of 2, and it's a line, so I know that this is going to happen halfway between 3 and 4, and I'm going to say g inverse of 5 is 3.5. For e, okay, again, like I was telling you with the table, I already know this is going to be 3. But I'm going to say, all right, well, g inverse of 3 is where g of x equals 3. I thought I already did that. I guess I did not. That's going to give me 2.5. And then I'm going to take g of 2.5, and it's going to give me 3. So g of g inverse of 3 is equal to 3. And g inverse of g of -3, that's also going to be -3. Because g of -3 is this -1/2. And if I take g inverse of -1/2, I go to y equals -1/2, trace it back to the x. Oh, yeah, that gave me back -3. Hey, so that's it. That's all for this homework. Thanks for watching. You know, if you feel like you need more, go back to the extra practice in the notes book because it has more of those algebraic solving for the inverse ones. And I'm pretty sure, yeah, I will have recorded that along with the lesson. So that's it. Thanks for watching. Hope this helped.